Come with me on a journey. We are voyagers, traveling not through space, but through time. Our vessel is the James Webb Space Telescope, a magnificent machine designed to look back toward the dawn of the universe. It is a golden eye, larger and more powerful than any that has come before it. Recently, this incredible instrument has shown us something astonishing, something that was hidden from us until now. It has unveiled a secret gathering of giants in the distant cosmos. Scientists, using Webb's powerful vision, have found 41 galaxies, each one cradling an actively growing black hole at its heart. These are not the quiet, sleeping giants we know, but hungry monsters feeding and swelling in size in the universe's youth. The universe is vast and full of mysteries. For a long time we have tried to piece together its story, to understand how everything we see came to be. Black holes are a crucial part of that cosmic puzzle. They are objects with gravity so strong that nothing, not even light, can escape their pull. We knew they existed, but seeing them, especially the ones that are actively growing in the early universe, has always been a challenge. They are often shrouded in thick clouds of gas and dust, a cosmic veil that blocks the view of older telescopes. But the James Webb Space Telescope, or JWST, was built to see the unseen, to capture the light that has traveled for billions of years to reach us. This discovery is more than just a headcount of black holes. It's like finding a new chapter in the epic story of the cosmos. These 41 active black holes are like cosmic lighthouses, shining from a time when the universe was much younger than it is today. By finding them, we can start to ask bigger questions. How did these cosmic behemoths get so big, so quickly? What is their relationship with the galaxies they live in? Are they the architects of galaxies, or are they simply passengers along for the ride? The light from these distant objects holds the clues, and for the first time, we have a tool powerful enough to read them. Imagine looking at a distant city at night. You can see the bright lights, but the darker alleys and hidden corners are invisible. Previous telescopes were like that. They could see the brightest objects, the most energetic black holes. But JWST can see into those darker corners. It has revealed a population of fainter, more common black holes that were always there, but just beyond our sight. This gives us a more complete picture, a more honest census of what was happening in the early universe. We are no longer just seeing the exceptions. We are starting to see the rules that governed the cosmos billions of years ago. How did the Webb telescope achieve this remarkable feat? The secret lies in its ability to see a special kind of light called infrared light. Our eyes can only see a small part of the light spectrum, what we call visible light. But the universe is glowing with all sorts of light, much of it invisible to us. The early universe in particular is a place filled with vast clouds of cosmic dust. This dust acts like a thick fog, blocking visible light and hiding whatever lies behind it. For telescopes like Hubble, which primarily sees invisible and ultraviolet light, this dust is an impenetrable wall, leaving much of the young universe in shadow. The James Webb Space Telescope was designed specifically to overcome this problem. It is an infrared observatory. Infrared light has a longer wavelength than visible light, which allows it to pass right through those dense clouds of dust without being scattered or absorbed. Think of it like this. On a foggy day, you might not be able to see the headlights of a car, but you might feel the heat from its engine. Webb sees that heat, that infrared glow, from the universe. This allows it to peer into the dusty hearts of the most distant galaxies and see the active black holes that were previously hidden from our view. This new view comes to us from a special project called the Cosmic Evolution Early Release Science Survey, or SEERS. This survey pointed Webb at a patch of the sky and just stared, collecting faint light for a long time. The goal was to map a slice of the early universe in unprecedented detail. What the SEERS survey found was spectacular. It revealed actively growing black holes that were 8 times fainter than any we had been able to detect before. It's like we were listening for whispers in a crowded room, and Webb gave us a microphone sensitive enough to hear them for the very first time. Finding these objects is just the first step. The light Webb collects is full of information. When material like gas and dust spirals into a black hole, it gets incredibly hot and shines brightly, especially in infrared light. By analyzing the brightness and colors of this light, scientists can figure out just how much material the black hole is swallowing. They can measure its growth rate. This is like watching a baby grow, but instead of measuring height and weight, we are measuring the light from a cosmic engine billions of light years away. This is the power that Webb has given us. With this new data, scientists could begin to connect the dots across cosmic history. They took the information about the brightness of these 41 black holes and used it to build a model. This model, called a luminosity function, is a way of charting the activity of the entire black hole population over billions of years. It's like creating a growth chart for all the black holes in the universe. What this chart showed was a fascinating pattern. It suggested that the activity of black holes, their feeding frenzy, started to increase in the very early universe. It wasn't a constant process. This period of intense black hole growth appears to have reached its peak about 4 billion years after the Big Bang. After this cosmic lunchtime, the activity started to slow down, and it has been declining ever since. The universe, it seems, has become a quieter place. The era of the most ravenous black holes is in our distant past. This timeline provides a crucial piece of the puzzle of cosmic evolution. It tells us not just that black holes grow, but when they grew the most. This rhythm of growth is a clue to the forces that shape the galaxies we see around us today. What makes this discovery even more profound is that this timeline looks very familiar. It almost perfectly mirrors another grand cosmic process, star formation. Scientists have long known that the universe went through a baby boom of its own, a period when stars were being born at a furious rate. This era of peak star formation also happened in the early universe and reached its maximum at around the same time as the peak of black hole activity. This can't be a coincidence. It strongly suggests that the growth of supermassive black holes and the birth of stars are deeply connected. This connection poses some of the most exciting questions in astronomy. Are the black holes influencing the stars, or are the stars influencing the black holes? Perhaps the same cosmic conditions, like an abundance of cold gas in galaxies, fueled both processes at the same time. Maybe the powerful winds and radiation blasting from a feeding black hole could trigger bursts of star formation in the surrounding galaxy. Or conversely, maybe the process could shut down star formation. We don't have the final answers yet, but seeing these two major cosmic events dance to the same rhythm across billions of years is a giant leap forward. It is important to remember that this is just the beginning of the story. This incredible research is based on the first wave of data from a single survey. Finding 41 growing black holes is a fantastic start, but it is a small sample when we consider the sheer number of galaxies in the observable universe. Scientists consider this a preliminary study, a tantalizing glimpse of what is to come. It's like reading the first page of a thrilling mystery novel. We have met the characters and seen the first clue, but the full plot is yet to unfold. The universe still holds many of its secrets close. The road ahead is clear. Future studies using the James Webb Space Telescope will expand on this work. Scientists will conduct more surveys pointing Webb at different parts of the sky to find thousands more of these hidden growing black holes. With a much larger sample size, they can build more accurate models and test their ideas about the connection between black holes and star formation. We will be able to refine our timeline of cosmic history and understand the link between these two powerful forces with much greater certainty. This is how science works. One discovery opens the door to a dozen new questions, and each question leads us closer to the truth. Why does all this matter? Understanding the history of black holes is fundamental to understanding our own cosmic origins. The galaxies we see today, including our own Milky Way, are the products of billions of years of evolution. The supermassive black holes at their centers were not just passive residents, they were active participants in shaping their environments. By studying how they grew and interacted with their host galaxies, we learn how the structures of the universe were built. We are, in a very real sense, studying the ancient history of our own cosmic neighborhood. The quest for knowledge is one of the noblest parts of the human spirit. We look up at the night sky and we wonder. The James Webb Space Telescope is the ultimate expression of that curiosity. It extends our senses across space and time, allowing us to witness the universe's formative years. The discovery of these hidden black holes is not an endpoint, it is an invitation. An invitation to keep looking, to keep questioning, and to continue piecing together the grand, unfinished story of the cosmos. And what a story it is turning out to be.